Alright, in this next set of videos, we're going to talk about one-to-one functions and inverse functions in section 6.2. We'll talk about the one-to-one functions in a later video. The inverses are where I want to start this. And just give you a definition. We've dealt with a lot of functions now, inputs and outputs, and we've dealt with compositions of functions along with combining them in other ways like adding, subtracting, multiplying, dividing. So now we're going to talk about looking at pairs of functions, in particular these inverses. Inverse functions are by definition two functions where the inputs and outputs switch places. Okay, so two functions where the inputs and outputs switch places. Give you a quick example. Let's just say I had a function f of x, and I just look at a quick table of values here. I'll just throw some things in there, 0, 1, 2 as the inputs, and let's say the outputs are 4, 8, 12. Okay, so that function has inputs. An input of 0 gives you an output of 4, input of 1 gives you an output of 8, input of 2 gives you an output of 12. The inverse function, which would be denoted as f with a superscript of 1, looks like an exponent, but really it's a superscript. It's just the notation for an inverse. So we have a function and its inverse. What happens is the inputs and the outputs switch places. All that means is all the inputs for one function become the outputs for the other function, and the outputs from the first become the inputs for the second. Okay. Very simple idea. You just switch the order of the ordered pairs. And so this first function, 2, 12, is one of the points on the graph, one of the ordered pairs. In the second function, 12, 2 is an ordered pair. And so every ordered pair, the coordinates switch position. Okay, so the coordinates switch position in every ordered pair. Okay, the coordinates switch position in every ordered pair. Okay, so that being said, if you look at these two lists as the domain and the range of a function, remember, domain of the x's, the range of the set of y values, then they switch places in the other function, right? So the range of one becomes the domain of the other, the domain of one becomes the range of the other. So you have this weird situation where the domains and ranges switch places as well. The domain and the range is, again, just the set of inputs and outputs respectively. Okay, so these are just some consequences of the definition. Now, if I give you a function, let's say I had, so these are easy. If you just have the points, you just interchange the numbers, the coordinates. But if you had a function in equation form, like 2x minus 5, right? F of x equals 2x minus 5. Then in order to find the inverse, like if I don't know what the f inverse is, then I would need to switch the inputs and the outputs. Well, how do I do that for all of the inputs and outputs, especially for a line where there's an infinite number of both of them? Well, it's simple. The inputs represent the x values, the outputs represent the y values, and so you simply rewrite this using a y, right, a y and an x, and then you switch them. You switch the y, it becomes an x, and the x becomes a y. Okay, so the first thing you do is switch the variables. Okay, you switch the variables. Then, we're always solving for y to get the function notation, so let's do that. Let's solve for y. I want to add 5 to both sides. So I get x plus 5 is equal to 2y. And then we divide both sides by 2. And we're going to be left with a y equals x plus 5 over 2. I switched sides of the equation. That shouldn't matter too much. Okay, so those 2's canceled. Now, there are multiple different ways to represent this function. You can leave it as one big fraction. You could also rewrite it by distributing the denominator to the numerator. Get x over 2 plus 5 over 2. You could even put it in decimal form. What's that? 0.5x plus 2.5, right? Half x, 2.5x, or 2.5 is a constant. Any of those will probably work. I should give you my second step here, which was to solve for y. Specifically, solving for the new y. Okay. And finally, the final inverse is just to take whatever form of this you prefer, or actually my math lab prefers, and I'm guessing they're going to prefer the fractions. And just write it with this inverse notation we looked at a moment ago, which is f inverse of x equals, I'm going to call this 1/2 x plus 5/2. Then it's in your slope-intercept form. Okay, so that allows us to find the inverse from a given function. All right, this two-step process, essentially, switching the variables and then solving for the new y, will always be the method you're going to use to find an inverse when given an equation.